So this is a question here. We have two infinite line charge wires, this one and this one. Their locations are a comma 0 comma 0 and minus a comma 0 comma 0, that we can say equidistant on x-axis. They are placed in the xz plane. The xz plane, this plane is xz plane because it is made up of x-axis and z-axis, and the y-axis is perpendicular to this plane. Y-axis is perpendicular to the plane of the wires. Now you have to find out the electric field at the following points. The first point is 1, 0 comma 0 comma 0, as you can see here, 0 comma 0 comma 0, this one. The second point is 2a comma 0 comma 0, 2a comma 0 comma 0, where it is going to lie here. So let me draw this. This is your second point, 2a comma 0 comma 0. And the third point is 0 comma a comma 0. So that could be your third point. It is on the y-axis. This is the third point, and here you have to find out the field. First of all, we have to know what is the field due to an infinite wire, and there is nothing to know, that was already discussed, but for specific reasons I want you to understand here the field due to an infinite wire. The field due to an infinite wire is always away from the wire, radially away from the wire, so that it always makes cylindrical surfaces around the wire. This is the field due to an infinite wire. So let's move on to the solution. So here is x-axis, y-axis, and I have two charges, or two charged infinite wires exactly. This is minus lambda, this is lambda, and I have to find out the field at the origin, 0 comma 0 comma 0. The field at the origin due to minus lambda will be towards, I forgot to mention this before, let me mention this again. If I have a negatively charged wire, the field lines, instead of going out, will be closing in. So again they will make a cylindrical surface, but instead of going out they will be closing in. So that's the scenario here if there is an infinite wire. So the field due to this negative infinite wire will be closing in or coming towards the wire, and what is its value going to be? Let me call this as E1, and the E1 is going to be 2k lambda divided by A. What is A? A is the distance. Likewise, the field due to positive charge here will be away. So let me draw that too. It will be away and it will be E2. So what is E2 going to be? Again 2k lambda by A. So what is the net field going to be? E1 plus E2, and that is 4k lambda by A along negative x-axis, minus I cap. Alright, next case scenario, again x-axis and y-axis. These are the two wires. These are the two wires, minus lambda and lambda. Where do we have to find the field now? The field which we have to find is here. This is the second point, 2a comma 0 comma 0. Again, the field due to the negative charge here is going to be towards, so let me call this as E1, and the field due to positive charge, this charged wire here, infinite, is going to be away, E2. Now how much is E1 going to be? E1 is going to be 2k lambda by the distance. Now how much is the distance? So let's take this into consideration. This is A, this is A. and this is A. The distance between negative lambda and origin is A, origin and positive lambda is A, and between the positive lambda and the point P where you have to find the field, the distance is A. So what is the distance between negative lambda and the point P? This distance, negative lambda and point P, it is going to be 3A. Okay, so what is E2 going to be? 2k lambda upon, what is the distance? That is A. Now, what will be the net field? The net field will be obviously E2 minus E1. As you can see, E2 is forwards, E1 is backwards. So 2k lambda by A minus 2k lambda by 3A. And that is going to be 4k lambda by 3A along the positive x-axis. That is going to be your vector direction of the field. Now consider the third case. This is minus lambda, this is lambda, and we have to find field here. This is the third point, 0 comma A comma 0. Now again E1 is going to be towards and E2 is going to be away. This is E1 and this is E2. Now this distance is A, this distance is A, this distance is A, and you see the how do I put it? The distances between the point P and the two charged wires is obviously root 2A and root 2A. Let me draw the diagram separately. So okay, so there is an E1, this is point P, there is an E2, and you will notice that E1 and E2, both E1 and E2 will have same magnitudes. The magnitude wise E1 equals to E2 equals to 2k lambda by the distance. And what is this distance or this distance? Both distances are root 2a. So by root 2a. So this is your thing. Now let's come to the angles, because we need to find out the components. You can't just add two vectors which are in separate directions. So you can see this angle is 45 degrees and likewise this angle is also 45 degrees. 45 degrees being, you will notice that the vertical components, the y-axis components of the fields will get cancelled out and the x-axis components of the fields will get added up. So what is the net field? The net field is going to be E1 cos 45 plus E2 cos 45. So that is going to be so that is going to be 2k lambda by 2a plus 2k lambda by 2a, and that will be equals to 2k lambda by a. And what is the direction? You must notice the direction here. The direction is along the negative x-axis. So if I mention the field with direction, the net field is going to be 2k lambda by a along minus I cap. So this is another question. A charged particle minus q, you can see here, is moving in a circular path. This is the circular path. Due to the influence of this infinite line charge, you have to find the time period of circular motion. You have to find the time period of circular motion. So how do we do that? So first of all, we must understand that the field due to the infinite line charge will be in this direction, and since charge is negative, the force will be opposite to the field, minus q into E. So that will be equals to the magnitude of force. We are just writing the magnitude of the force, q into 2k lambda by r, where r is the radius of the circle, or 2k q lambda by r. Now this force, as you might notice, will act towards, opposite to the direction of field. And what is towards? Towards is the center of the circle. So this force will also act as the centripetal force. So 2k q lambda by r is also the centripetal force, so that will be equals to mv square by r. R gets out of the scene, you will get v equals to root under 2k q lambda upon m. Now how do you find the time period? The time period is very simple, t equals to 2 pi r divided by v. You will solve for it. That will be equals to 2 pi r root under m upon 2 k q lambda. So this is a question. I have 3 semi-infinite rods. You might want to look. These are your 3 semi-infinite rods, uniformly charged. One of them is negatively charged. You can see C here is negatively charged, and 2 others are positively charged. A and B are positively charged and kept perpendicular to the plane of the paper. So if this is the plane of the paper, these rods are perpendicular to the plane of the paper. You can say coming out of the plane of the paper, such that their finite ends are at A, B and C. So the finite ends, what do we mean by finite ends? The ends that, the ends that we know of, that for those finite ends are at A, B and C. Now if you are getting confused with this, you can shift mentally to this diagram here. Same circle drawn with a different perspective. You can see the 3 rods also. Two of them are positively charged, one of them is negatively charged, and their finite ends are at points A, B and C. And you have to find the electric field at this point O. You have to find the electric field at point O. Now we do remember, of course, that what is the electric field due to an semi-infinite wire. Let me draw this here. Semi-infinite wire, there are 2 fields, E perpendicular and E parallel. Both are k lambda by r, where r is the radius obviously, or the distance, whatever you like to call it, and it is for positively charged. What will happen for negatively charged? For negatively charged, the direction will get reversed. E perpendicular will be towards the wire, E parallel will be upwards direction. So now we want to find out the field at point O, and we should change the page. So I've changed the diagrams and you will see this here. So these are your 3 infinite wires, A, B and C. Let me draw this in red because there will be confusion. C is negatively charged, B is positively charged in blue, you can notice, and A is also positively charged. Now we have to find out the field O, and for that I have taken 3 separate diagrams, due to A, due to B, due to A, due to wire at B, due to wire at C, and these are my 3 separate diagrams that will help solve the problem. So let's start working on it. The field due to wire at A will be having 2 components. E parallel will be equals to k lambda by r, and E perpendicular will be equals to k lambda by r. That will be E perpendicular. So I'll draw the field lines here. due to A. This will be E parallel and this will be E perpendicular. Now how about field due to B? Field due to B, due to field B here, due to B here. So I'll take another color here. You'll have E perpendicular and E parallel. Same values, k lambda by r and k lambda by r, so you don't need to fuss about the values there. So I'll draw this in yellow, E perpendicular and E perpendicular, E perpendicular and E parallel. Again, due to the negatively charged wire C, due to the negatively charged wire C, you'll have in the reverse direction, basically the direction will be reversed. So this will be your E perpendicular and this will be your E parallel. So let me show this in green. This will be my E parallel and this in this direction will be E perpendicular. So let's talk about parallels first. What do you see? There are three parallels, this one and this one, out of which two parallels are in the same direction and one parallel is in downwards and the one parallel is upwards. So what will be the net E parallel? What will be the net E parallel, summation of E parallels? That will be k lambda by r and it will be in the downward direction. Now let's talk about E perpendiculars. You can see there are three E perpendiculars, this one and the red one I have drawn very small or short, so I'll extend that line. So this one here, these are your three E perpendiculars. The red one is due to A, the yellow one is due to B and the green one is due to C, obviously. So how do you find out the net E perpendicular? For that, we need to draw a diagram, a two-dimensional diagram as a matter of fact. Okay. So this was A, this was B and this was C and this was O, obviously. The direction of E perpendicular for A went like this. The direction of E perpendicular for B went like this, again because it was positively charged, and the direction of E perpendicular for C went like this because it was negatively charged. So what do we think of these angles? You might say that, let me draw the diagram. The E perpendiculars, these two E perpendiculars are at 120 degrees from each other. This was, please do remember, this was the E perpendicular due to B and this was the E perpendicular due to A, and they are at 120 degrees with each other. And what will be their resultant? Obviously their resultant will be somewhere along the angle bisector, and you can very easily find out root under E perpendicular squared plus 2E perpendicular squared cos 120, that is minus half, and that will be equals to E perpendicular. So this will be your E perpendicular. Plus we are forgetting one more E perpendicular that was due to C, so that is E perpendicular. So what is the net sum of E perpendiculars? The net sum of E perpendiculars is 2 E perpendiculars along what? Along OC, this line, along OC. So the 2E perpendiculars will be 2k lambda by r along OC. So how do we how do we summarize this? Okay, so to summarize this, let's draw the circle again. And this is point A. This is somewhere here is point B, and let's say this is point C, and this is O, the center, obviously. Now, what was the direction of E parallel? Do you remember? The direction of E parallel was perpendicular to the plane of the circle downwards, and that was K lambda by R. What was the direction of E perpendicular? Net E perpendicular? That was 2K lambda by R along OC. You can just rewind the video and watch it again. And the resultant of these two vectors will be somewhere in between the circle, somewhere in between the plane of the circle, and in the perpendicular to the plane. So let's see what is the resultant. So this is the resultant, and let's say it makes an angle theta. So tan theta is going to be perpendicular by base. So please notice this is the perpendicular and this is the base, because this is the line that is joined with theta and this is the line that is not joined with theta, that is perpendicular to theta, or complementary to theta, not perpendicular but complementary to theta. So tan theta is going to be E parallel by E perpendicular, and that is going to be 1 by 2.